Okay, so we have a 3 kilogram block starting from rest at the top of a 30-degree incline, accelerating uniformly down the incline plane, moving 2 meters in 1.5 seconds. So before I even get into the body of questions, all physics problems should start with what do I know, what do I not know. So I've got an incline that makes a 30-degree angle. Let me see if I have a thinner line. There we go. So I have a 30-degree angle. And I have a box that's at rest. So I know my initial velocity is 0 meters per second squared. And it's 3 kilograms. Mass equals 3 kilograms, and I know that the change in x is 2 meters, and the change in time is 1.5 seconds. And so that's everything I know right now. I don't know the weight, I don't know the acceleration, I don't know the final velocity. So now let's start calculating what we can know. So let's do red for gravity. So I know that F baby G is going to be equal to negative 9.81 times 3, because force is mass times acceleration. The acceleration due to gravity is negative 9.81. That's negative 29.43 newtons. Great. And so I also can then find out from that it's going to have a force this direction, downward, and a force this direction. And so I think what would be helpful, and that'll make a 90-degree angle, I think what would be helpful is I'm going to define my axis as x direction, y direction. That way I can just have positive numbers and negative numbers and not have to worry about it. So if I do trig, I know that this angle here is the same as that angle. So that's 30 degrees. And so I can do negative 29.43 sine of 30 and get negative 14.72 newtons. Actually, we'll do 715 newtons. And then negative 29.43 cosine of 30 degrees will give me negative 25.487 newtons. And so if there's negative 25.487 newtons going down, and that means I have a normal force of equal magnitude because my box is staying in contact with the ramp. It's not floating away and it's not falling through the ramp. So it has to also be 25.487 newtons. Alright, so far that's all I've been able to figure out. The rest of it I'm going to have to do some calculation. Well, the first step, it says find the magnitude of the acceleration. And I know you're going to want to try to do F net equals mass times acceleration, but we don't know the net force. This is actually where you're going to have to use your kinematic equations. And there's a clue word in here. Uniform acceleration. That remembers that we have to do kinematic equations. So I don't know the final velocity, and I don't know the acceleration. So what can I use to find that acceleration given the initial, the change in distance, and time? Yeah, it's the classic 2 equals initial velocity times time plus 1/2 acceleration times time squared. And so that's null. And so if I take 2 equal to 1/2 a times 1.5, I'll end up having to get 2 equals, let's see, 1.5 squared divided by 2 is 1.125. A times 1.125. I divide each side by 1.125. And so I get an acceleration of 1.778. And it's going down the hill. So it's negative 2 meters. That's how we can get that negative direction, is my acceleration. And that's in meters per second squared. So that was letter A. Done. So I get kind of frustrated when they do this. Letter B asks for the coefficient of kinetic friction, and letter C asks for the magnitude. Well, we can't find the coefficient without knowing the magnitude. So you can't find the answer to letter B until you do letter C. And so let's think about that. This is where we have to kind of go back and forth between the two. We have an acceleration, we have a mass, and so we know the net force, F net, has to equal mass times acceleration. And so my net force has to equal negative 5.334 newtons. So I have to be having a net force going this way of 5.334 newtons. Well, I already know that my box is falling that way due to gravity with negative 14.715 newtons. So what would friction have to be going this way to change negative 14.715 into negative 5.334? And the best way to do that is just to take negative 14.715 and subtract negative 5.334. And you'll get, you want to take the negative 14.715, and so it'll be going 9.381 in the opposite direction. Because that makes sense. Positive 9.381 plus negative 14.715 gives me negative 5.334. And that number, that force, is what's needed to make a mass of 3 kilograms accelerate at a rate of 1.778. And so this force right here, this 9.381, that is my force due to friction. Yeah, and I just found my acceleration is negative 1.778 meters per second squared. That's in newtons. Now that I know my normal force and my force of friction, the coefficient of friction is my force due to friction divided by my normal force. And so when you do that, you get a 0.368. And remember, it's a coefficient, so it's unitless. So the very last thing we have to do is find the speed of the block after it has slid a distance of 2 meters. But you can use whatever you want. You can use the classic again, or I'm sorry, not the classic. You can use the tail of 2 squareds. B squared equals initial squared plus 2ax. Or you could use final velocity is initial velocity plus acceleration times time. Either one of those will get you to the answer. I'm going to use this one because it's less squaring and screwing that I have to do. So my final velocity is equal to 0 plus negative 1.778 times 1.5. And when I do that, I'll get a negative 2.667 meters per second. So after 1.5 seconds, I've moved 2 meters. I'll be going a velocity of 2.667 in the negative direction. And that's basically it. A lot going on, but as always, you start with what you know, and you work from there. That's all.